want to say welcome to today's EnRoute webinar. We appreciate you taking time out of your busy day to spend it with us, learn a little bit more about EnRoute. Today, our presenter will be Aaron Clapp. You probably already know him. He is the Director of Training here at SAI and knows EnRoute inside and out. And today, he's going to be talking a little bit about cutting in 2.5D in EnRoute. And so he'll be going over the details of getting those cuts. And we'll do that for about 15-20 minutes, and then we'll open it up for questions. So we may go a little bit longer today. I think there's a lot of content to cover, but then we'll open it up for some questions. You can just type them into the chat window. So if you think of any you'd like to ask during the presentation, just go ahead and type them in. And we'll answer as many of those as we have time for today. And we will be recording today's presentation. So we'll send a link to the YouTube video after we have it uploaded, so you can review it anytime. And I believe that is everything. So Aaron, why don't you take it away?
All right, sounds good. So we want to take a look at 2.5D in EnRoute. And first, I guess we should probably start with what 2.5D is and what that means for EnRoute. So in EnRoute lingo, 2.5D is somewhere in between cutting a full 3D piece and routing something out like a simple square or any kind of other parts, right? So 2.5D kind of bridges the gap in between the two, where when we're doing 2.5D cuts, we're referring to a type of cut that uses the profile of the tool in order to create a three-dimensional cut that doesn't require us to insert any modeling, no 3D, no reliefs, none of that is required. And so inherently, we're going to be able to create 3D looking patterns, shapes, cuts without having to go into all the work of doing 3D. We're going to simply leverage the power of the profile of the tool in order to create some of these things. The advantages of doing this is that we can simply, much simpler and much easier and much quicker, create these tool paths as we go along. So let's kind of start with a few things here. So what we want to do is we're going to start with our engrave only option. So this is kind of where we're going to start. Now there's all kinds of different applications where we can take this, and we want to be able to start with something simple, and we're going to work our way through all this stuff here in a minute. So first of all, the first toolpath that qualifies for the 2.5D is going to be a simple engrave. We can do this in several different ways. What I've done here is I've actually created two different sets of text. Now this is using an open line font. So if you don't have any of these, you actually get 3 of them inside of EnRoute. You got 3 of them inside of EnRoute. They're called ER Basic, ER Script, and ER Print. They look kind of weird in the previews, but they are single stroke fonts. Single stroke fonts are really great actually for doing like V-groove text and stuff like that. V-groove letters and things like that are all going to be considered 2.5D in EnRoute. So you can add single stroke fonts to your software if you want to. One of the places that you can do this at as is, I think it's a place called onelinefonts.com. And that actually we support a lot of their fonts. So if you're looking for more single stroke style fonts like this, then that's where you'd find those. And then you would just put those into your Windows Fonts folder and restart EnRoute, and you should get access to those. So the next thing is we want to take a look at, so what does this look like? So let's just apply an engrave toolpath. I'm going to clear everything out here for the moment, and I'm going to come in here and I'm going to use a conic tool. I'm going to use our 90-degree conic, and I'm just going to give it a specified depth of 1/4 of an inch, and we're just going to apply this. For now, we're going to make sure that the follow contour option is unchecked and the 3D engrave toolpath is unchecked as well. What this basically does is this obviously just plunges the bit into the material at a given depth. Pretty simple. This is not really rocket science in any way. This kind of just gives you really basic V-groove letters. And so if we go to preview this, we'll kind of see what this looks like. Actually, I'm going to click the little button. Here we go. You only need to, well, now we're having some kind of problem. All right, I'm going to save my file here. I'm going to reopen EnRoute just for a moment. I was actually testing a bunch of files right before this, so that's probably what it is. I probably broke something in EnRoute. So here we go. All right, grab this, preview, save simulator. Okay, there we go. Let's bump this down. We don't need it to be that big. There we go. Okay, so real basic. Obviously here we've got a nice clean look with this single stroke font. And then we have this text down here. Now we're gonna talk about how to get into this part where we clear out the center text. But you could see here that we've got a nice exterior cut. And then if you wanted to add a routing offset to this, you would have a flat plateau with a nice angled section here, and then you could cut out the inside. So this would be another really great way to create some textured looking or raised letters with a flat top on them, or to simply create your very simple V-groove style letters just using the engrave. So that's where we get started. Where we want to really go to next is going to be our 3D engrave, and how our 3D engrave uses the text in order for us to get into this. So we'll go to our top view here, and I've got a couple letters. And now this time, what we've done is this time we've created two different tools, and I've used some different settings. So I'm going to go ahead and select this. I'm going to right click and say edit this toolpath, and we're going to look at the settings that we've used. So in this particular instance, I have chosen to click the box for 3D engrave toolpath. What this does is this takes a measurement of the letters that you have, and it tells the software, well, we tell the software how deep we want to go. And what's going to happen here is as it cuts through the file, the deeper parts of the letters will go, or the wider parts of the letters will go deeper, and the skinnier parts of the letters, the bit is going to retract. And what this allows us to do is it does not allow any of the letter to blow out or go past our boundary of the letter, which is really nice. Actually, let's go back to this real quick. I don't know if you guys noticed this. When we did this preview, and let's just run this preview again so we can see it. One of the disadvantages of just running a plain old engrave on normal font like this is problems like this right here. See how this letter kind of invades here and here? This is something that the 3D engrave is not going to allow. So I'm going to go back to my 3D engrave here. And when I look at this, my toolpath will never exceed the boundaries of the letter itself or of the object that you have selected. So this could be a rectangle, a square, a triangle, any other shape that you're applying this to. It will never allow the bit to cut past the boundary of the object or the letter. So that makes it really nice because I know when I cut this out, I'm going to get nice, clean, crisp letters. So the way that I've done this is, again, I select my toolpath here, I go to engrave, and when I do that, I just make sure and click the option for engrave toolpath. Now, I can assign my depth here, and this is a maximum depth. This is not going to be a true depth. So this does not mean that every single part of the letter is going to go to 0.75 inches. It just means that it will go to a maximum of 0.75 inches if there's areas in the letter that will allow the bit to go that deep. So we can hit apply and OK. Let's take a look at this one here. We've done the same basic thing here, except for the only difference, we still have the 3D engrave applied, same depth, but we've used a slightly different tool. So in this particular case, what we want to do is when we look at this, we see that we're going to get a very similar style cut, except for fewer passes. So you'll notice here with our 90-degree conic at the top, it's making two more passes than the 120-degree conic is. And then we're also getting, we're going to get the same cut. So why don't we go ahead and preview this and see what this looks like. I'm going to grab my shape here. And by the way, when I do this, this is just a little pro tip, and I think we've mentioned this in some of our other webinars when we talked about 3D. But anytime I want to preview something, draw a box around the area that you want to preview and then highlight it. When you go to your 3D render option and then you click this option that says use selected contours as a mask, this will actually only allow you to preview this little section. Then you can actually bump up the resolution and it's not as big of a deal. So I can go much higher on my resolution and it's not as big of a deal. And that allows you to not process the whole entire plate when it's really not necessary. There's no reason why I need to process the entire plate if all I need to preview is something that's up here in this top right-hand or top left-hand corner. That's why I'm doing that. So if you see me doing that, that's what I'm doing. It saves me a little bit of processing power and a little bit of time not having to re-render the entire plate. All right, I'm going to hit OK, play, and then the light bulb. And now when we zoom in here, we can see that basically we've gotten the same very, very similar cut. Now, this one down here at the bottom is not quite as deep in some areas. And you can kind of see that up here in the R, in the run, in the O, and the U. It's not quite as deep, but that's because we're using a more wide bit. But it took about half the amount of the time because of the half amount of toolpaths that there are. You'll also notice that up here at the 6, despite the fact that we were using a 120 conic tool and a 90-degree, these areas did not invade into the letter. So these are all going to be self-contained. So, and the corners, you can tell the corners, the bit lifts up in the corners to create those nice sharp edges there. So you kind of get nice, crisp, sharp edges. So that's going to be your 3D engrave toolpath. Now, one thing I kind of wanted to quickly show you as we take a look at this is I'm going to take the same, let's get this guy, let's just delete this one out of the way. I'm going to make this one, and I'm going to make it bigger. This, whoops, I meant to hold down Shift. There we go. I'm going to make this really, really big. And then I'm going to select this, and I'm going to change something about this toolpath. I'm going to have it only go to 0.25 inches. So you'll notice something that happens here. Because of the lack of depth that I've given it, I'm only allowed to go so deep. And so I've told it I can only go 2.25 inches. So that means that the toolpath is not going to cut out this center area. And let's go ahead and preview this. All right. So now we've kind of gotten a slightly different effect. And it's left the centers here in the middle uncut. Now there's going to be a way that we can handle this if we want to. So just be aware that the bigger the text, if you're using a 9-degree conic, you have to go deeper and deeper and deeper in order to get that very nice pyramid style shape. So you might actually need to consider using a larger bit if you're trying to use a 3D engrave on something that's really, really large. Now, sometimes you may not want this to come to a point. So you may just want it to have beveled edges, but then have the center smooth. And there's going to be there will be a way that we can deal with that here in a second. So be aware that if you don't put it deep enough, you will get that effect. So just be aware that that might happen to you. So let's take a look at our next layer. We're going to go to using an island fill and a 3D engrave at the same time. So one of the things that we looked at in the last example was that when we made the letters really large and we assigned a toolpath that wasn't quite deep enough, it left a lot of material in the middle that was uncut. So the way that we can handle that is we can actually use the island fill, and we're going to use 2 tools in order to create that effect. So you can see here in our toolpath, we've got a green line and a purple line. Green is going to be an end mill that's going to hog out the center to make sure that the center is flat. And then you've got the green toolpath, which is going to be your conic tool, which is performing the 3D engrave. So let's take a look at what this toolpath looks like. So I'm going to highlight this, right-click on it, and say Edit the Toolpath. So what I've done is the first tool always needs to be an end mill. So we're going to go ahead and set up the fill, and we're not going to do anything inside of our values in here. You can obviously do passes and things like that, but we're not going to do anything special inside the parameters here. The next thing I'm going to do is I'm going to apply a 90-degree conic. I'm going to let it be a clean pass. That's okay. And then I'm going to hit the 3 dots. And here's the important part. If your 90-degree conic is the second tool in the list, when you click on the 3 dots, you will see the 3D toolpath option appear. This is basically the 3D engrave option and nested inside of the island fill. So what we're going to do here is we're going to come through, we're going to cut through this. Well, I mean, either way, I mean, it depends on how you set up your ordering. It doesn't really matter which way you're going to cut it because the result is going to be the same. But the idea is that we're going to either cut with the 90-degree conic and then clean up the middle, or we'll clean up the middle first and then do the 90-degree conic after. Either way, we're going to get the same result. So that's what we have here. Now, I've done the same exact thing on this one, except for the only thing that I've done differently here is that this time I added an external boundary. So instead of highlighting the letters like this and toolpathing them, I selected the outside and toolpath them as well. And if we right-click and edit the toolpath, you'll notice it's the same tools, same depths, everything's the same. If I click on here, I've got my 3D options checked. So let's take a look at what these 3 now look like. So if I hit my preview, hit OK. All right, so this is what this looks like now. So now by using the island fill, what I've been able to do is I've been able to create a nice tapered edge with a flat bottom. Because with this particular style of letter, this letter is very, very large. I might not actually have enough material to create a V-groove letter at this size. If I try to, it might actually end up being like 2 inches deep. So maybe all I want to do in this case is create a flat area on the outside or on the inside, and then just create a beveled relief on the middle. Now, again, I can change this. I can change this to as much as I want. So if I want to make the angled part deeper, all I would have to do is make sure that the island fill and the engraved toolpath are going deeper. And so that's the only thing that I would need to change. And that would make this little slanted area or this beveled area nice and deep if I wanted to go deeper. One of the things you'll notice here, though, is that over on this 6, I used a too large of a tool. And so if I wanted to clean up this little tiny piece in here, I probably would want to use a slightly smaller tool instead of a 1/4-inch end mill. Maybe I go with like a, something else, a 3/16 or something, just a little bit smaller that can fit in there and clean that little tiny little bit up. Now what we've done down here is basically the same thing. So what we've done is we've done the opposite. So instead of a V-groove letter with a flat bottom going down, we've created a kind of like a pyramid letter with a flat top. And everything else around it is carved out flat. So by using the island fill with the 3D engrave option, it can give you this ability to create unique cuts like this. The only thing that you just have to remember is that when you're setting those types of 3D engrave toolpaths up, you just need to make sure that the end mill always comes first, and then the conic is the second tool. If you try and reverse these around, what happens is you actually won't see the 3D engrave toolpath option to click on. So just be aware of that. So let's talk about the pyramid tool then. So now we've talked a lot about the 3D engrave and creating V-groove letters or using the profile of the tool to create those style of letters. Well, what happens if we use the pyramid tool? Well, the pyramid tool basically uses the same V-groove or the same conic tools, and it allows you to create pyramid letters based on the size of your geometry. So what I've done here is this is really simple geometry, same letters as I did before, and the only thing that I did was I highlighted this and I went to the pyramid tool right here. You can also find it under Toolpath, Pyramid. Now I'm going to pull up my settings that I was using before. Basically, what I did here is I just chose my 90-degree conic. So let's actually delete this because I want to show you what this will do. So we're going to highlight this. We're going to go to our pyramid tool, conic, and when you'll see look at what happens with the depth. When I hit the double click on the 90-degree conic tool, it automatically assigns a depth for me. So basically, EnRoute looks at your geometry and says, okay, based on the geometry that you have selected, I would need to cut 0.8505 inches deep in order to make sure that shows up as a pyramid letter. So just know that that's the case, and you can find out what kind of material. So in this case, I would need something like a 1-inch piece of material in order to be able to cut this properly. If I clear this tool out and I go with the 60-degree conic, now I need 1.5-inch material in order to make a pyramid letter using this geometry with a 60-degree conic. And of course, if I go with a 120, then it only needs a 1/2 inch material. So based on the tool that you have, EnRoute will automatically assign a depth and then apply it. So I'm going to hit OK on this one, and then I'm going to duplicate it, clear off the toolpath, and then I'm going to use one with a 90-degree conic. We'll do both of these. So you can see here that the toolpaths that is created are fewer for the 120, and then for the 90, there's a lot more because it's got to do quite a few more passes in order to successfully hog out this entire area. So let's look at the preview and see what this looks like. And actually, one other thing I'm going to do is I'm going to actually just grab these and I'm going to throw a routing offset on these just so that we can cut out the edge, so that we can kind of better see what that's going to look like separated from everything. No? Okay, so now what we've done is we've created some nice pyramid letters. So here, up here is using the bigger tool, the 120. So if we look at this kind of from this angle here, they're not quite as steep. So they're a little more angular. These are much steeper because this is using the 90-degree conic. And then you can see that what we did was we used that little end mill to kind of carve out the edges. So we got this nice freestanding letter that we can take a look at. So we've got a nice pyramid letter based off the tool. And the good thing is that these cuts are fairly simple to do, and they don't require tons and tons of 3D time. You can create these same letters using 3D and have them cut out with a ball end mill, and they'll take 3 to 4 times as long to cut out because you're cutting them out with a ball end mill or some other tool. Using the pyramid tool or using the 3D engrave tool actually maximizes the profile of the tool and knows exactly what to do and how to get the most out of it so that you're not running circles around, your cuts. Again, we can see how in this particular one, because we used a sharper tool, it had to use more of the depth of the material in order to create the proper angular pyramid cut, but it still fit in the material, and then we cut it out around the edge. So that's a really easy way to create some nice 3D letters. Again, this could be you could use this in conjunction with other things inside of a sign, or you could just cut these letters out that you might be, putting on a wall or mounting somewhere. However you want to do that, this could be useful. And you can also use this with a lot of other different tools too. There's the engrave tools and things like that that you can use. Some of these, I believe that the pyramid tool is very specific to conic tools. I don't know that it lets you use anything else. Oh, maybe it will. It will let you know if you can't use the tool. Basically, I think there's 1 or 2 of these functions that, here we go. So the pyramid tool must be capable of engraving. So you have to have a tool that is capable of engraving in order for that to work. So just be aware of that. So in this particular tool, you got to use a conic tool or an engrave tool or some kind of tapered tool that would have the ability to engrave. So that's the pyramid tool. So what else can we do with 2.5D? So we've got a couple other different examples here that we want to take a look at in order to kind of expand our what is the 2.5D. So here's a perfect example one, is project toolpaths to a plane. Now, I may have mentioned this toolpath in the past in some of the other videos, but I wanted to kind of hone in on what this tool does. Project toolpath to a plane is a tool that takes a normal 2D toolpath and creates it or turns it into a 3D toolpath. So let's just take a look at our side view here for a moment and look at what our 3D toolpath can do. So if we look at this, and I'm going to take this external cut here, I'm just going to take it off for a moment, it's easier to see. So this is a plain old engraved toolpath, nothing special about it. If I right click on, say, edit toolpath, it's a 120-degree conic tool that I set to a depth of 0.125. I'm not doing a 3D engrave, and I'm not doing a follow contour. Very basic, very simple. But I use the project toolpath to a plane to create an angled look. And here's how that looks. So I'm going to delete these toolpaths. Okay, so let's delete the toolpath. I'm going to take all three of these lines. We're going to start over. So what I did is I went to toolpaths and I just did an engrave. I set it to 0.125. I chose my 120-degree conic because this is the depth that I want this slot to go to. And essentially what we're going to do here, and now if we look at it, I just applied the toolpath. You can see that our I guess it's like a maroonish or kind of a brownish line is straight across the material. And I'm going to go ahead and apply my routing offset that I had here. And let's just preview this for fun, just to kind of see a before and after. So this is what this file looks like before I've applied any kind of other tools to it. So it's just a little groove that goes all the way across. All right, pretty simple, not anything super special. But let's say that I want the cut to start here and then slowly go deeper into the material as it progresses down the line. So I want to create some angled slots that kind of go down, or angled grooves that go deeper as they go. I'm going to edit this toolpath and make this a 1/4-inch end mill. Just so that we have that there. Okay, so now what I'm going to do is I'm going to take this line, and this line, and I'm going to go to my toolpath menu and say project toolpath to a plane. Now what I want to do is here I can say I can do all kinds of things here, but basically what we're doing is we're rotating the toolpath. So what I want to do is I could do this by angle or by height. In this particular case, I want to do it by height. So I'm going to say click on height, and then this is you're going to allow you to choose the rotational edge. So in this particular case, I want to rotate it from this edge over here on the left-hand side. So I'm going to choose this option here. If I wanted to rotate it from the right, from over here, then I would choose this option. Or if I wanted to rotate it from the top or the bottom, I can choose which angle. Then all I have to do is I tell it how deep or how much I want it to rotate. And so in this case, I want to rotate it to 0.75 inches. All I have to do then is I've got my height, hit apply. Doesn't look like much has happened, but when we look at it from the side view, we can now see that our toolpath has been rotated. So now it starts at 0.125 and goes from here all the way down to 0.75 inches down here at the bottom. Now let's preview this and take a look. I'm going to grab my tool here. Okay, play. And now, just like that, I have angled slots. So they start out at 0.125 and they go deeper and deeper and deeper until they get to 0.75 inches. So this is a really easy way to create a really simple slotted design like this. This allows you to do this to any toolpath, by the way. It doesn't just have to be an engraved toolpath. So let's look at another quick example here. Let's take I'm going to copy this E, paste it to the active layer here, and let's remove the toolpath. Let's just try an island fill. So let's do clear, and this may not turn out super well, but we'll try it here and see what happens. I'm going to go with a 0.25 again. Make this a little bit bigger, and let's change the tool. Let's change it to 1/4 inch. Okay, so I can then go back, select my toolpath, go to project toolpath to a plane. Maybe let's do it by angle this time. and then let's maybe rotate it this way and say maybe my angle is 4 degrees or something like that, or 0.4. Let's do 4 degrees. That's apply, close, look at it from the side, and you can see that we have gone and we have cut it at a 4-degree angle here. So now if we drag our preview over, now we've created a toolpath that is, we've created a slanted E. So just like that, we've created a really nice looking effect that you can use on literally almost any toolpath. I think the only ones that might not be able to do it are going to be like the drills and things like that. But most of your island fill, your hatch fills, routing offset, engraving toolpaths, all of those will do this. And so this is an easy way. Again, if you were to take this same letter and create this in 3D and cut it in 3D, you'd spend a significantly more amount of time running this through your simulation or running it through a full 3D type setup than you would just using the projected toolpath to a plane. One of the things that we really advocate is using the ability of your tools to their greatest extent as much as possible. So when we come into a file like this, we say, okay, you know, can we do this out of 2D or can we do this out of 2.5D? Because if we can, you'll save yourself so much time rather than having to build it in 3D, set up all the reliefs, and then go through the process of cutting it out with a ball end mill or something like that that could slow down the entire process. One last example that we want to take a look at here right as we finish up is here is a really good example of how we can use 2.5D in order to create some unique effects. So I'm going to go to rapid texture. Now, I'm not going to get into the nitty-gritty details of how to use rapid texture. We've done some videos of those in the past, so check out our YouTube. I've done some, there was an episode on our Workflow Wednesdays that we did. So if you look up that playlist, you'll see a playlist where me and Jesse, the product developer for EnRoute, go through step-by-step what to do for rapid texture and how to set this up. But I wanted to quick throw in a rapid texture and just kind of show you, what we can look for. So let's do a few things here. Let's apply this. Now, this is purely two-dimensional lines. These are just lines that are going up and down in a wave-like pattern in the X and the Y. And then also, if we zoom in from the front side, you'll notice that these lines are also going up and down in the Z. It's kind of hard to see. We'll get zoomed in here. So you can now see that these lines are just going up and down all over the place, right? They're kind of just all over. And so we're going to use this to our benefit. I'm going to select these lines. I'm going to choose my engrave toolpath. And in this case, it doesn't matter what depth I use. I'm going to use a 90-degree conic is what I would. Actually, you know what? Let's use a ball nose this time. Let's do something a little bit different. Let's do a 1/2-inch ball. It doesn't matter what depth I choose because I'm going to click the options for follow contour. When I click on follow contour, what that means is that EnRoute is going to force the tool to ignore the depth that you've told it to cut to, and it will follow the depth of the line. So it's going to follow these lines up and down in the Z wherever it goes. And so that's what the follow contour option is for. So if I hit OK, and now I'm going to go ahead and preview this. Whoops, I forgot to, let's do this. Nope. Again, I don't want to preview my entire plate. So I'm just going to preview a section. Oh. And that way we can look at it with a little bit higher quality and not suffer too much. Okay, so it's going to take a second here to process, but this is this will be using the profile of the tool to the maximum. So now we've created kind of a unique wavy-ish style texture that's pretty interesting. And you can put this on a panel door, as a wall panel, or anything like that. You could use this as. Now, the cool thing is that if I go back, let's go back here for a second, and I'm going to do one quick little change so you guys can see this a little bit better. I'm going to change the orientation of the light source just a little bit. Okay, and then what I'm going to do, I'm going to come back in here. Oops. This time, I'm going to delete the toolpaths, same engrave, and instead of a ball end mill, I'm going to clear that out, and this time we'll use a conic tool. Follow contour, okay. So just by changing the type of tool that I use is going to vastly change, how this file looks like when it's done cutting. So now you can kind of see here it's going through its preview, and now we got a slightly different pattern here. And so we could create some very unique and kind of interesting things based off of the profile of the tool that we use. You could use an end mill, you can use a ball nose, a conic tool, an engraved tool path, a tapered bit, anything. So just like that, by just switching out the tool, we've created two very unique and different looking patterns using the profile of the tool. This is the power of using the profile of the tool versus trying to do something like this in 3D. So hopefully this has kind of shown you some of the options that are available in EnRoute that you can use for 2.5D. There's a lot of other things that you can do as well, but these are some of the main ones. And hopefully this will kind of help you bridge out into doing some more things that are not just, avoid getting you into 3D. Because if you can avoid 3D, not that 3D is bad, 3D just tends to be a little more complicated, a little more involved, quite a bit more time consuming in terms of how long it takes to cut. So if you can create the same effect or something very, very similar with using the power of the profile of a tool, let's do that, because you'll save yourself time, money, effort. There's a lot of advantages to doing it with 2.5D and EnRoute. So at this point, do we have any questions about this or about anything on EnRoute? No questions. Did I cover it too well? Can rapid texture use project toolpath to a plane? Well, that's a really good question. Let's find out. Let's grab this. Project toolpath to a plane. I don't see why not. Let's do angle, and let's do 5 degrees. And then let's look at it from the side view. Let's see here. Let's get my zoom tool on here. It looks like it did one of the lines. Maybe that's because I had, hold on. It may not. Let's do this. Let's make this a little easier on my computer here, because I'm trying to do the streaming here and the rapid texture at the same time. So let's just simplify the rapid texture just a little bit. Let's grab these. I kind of want to say no. And the reason why that might be is because when I use the 3D and when I use the engrave toolpath, I tell it to follow the contour. And if the contour doesn't change, then that means that the toolpath is probably not going to change. So I want to say the answer to that question is no. But what you might be able to do is rotate the actual lines in the rapid texture before or after, well, probably before. I would say before you toolpath them. So delete your toolpaths, go into your precision input center, do a rotate, rotate these just a little bit, and then apply your toolpaths ahead of time. So to answer that question, no, because the toolpath is specifically tied to the contour in this particular case.
Excellent. So we had another question from Paul. Said, when you did the slanted E, I guess your only option for a flat bottom is to use a ball bit. Is that correct?
That E, let's see here. So in this particular case, it would, yeah, well, in this particular case, what would happen is when we go to preview this, let's go and look at it again. It's going to give you a fairly flat, but down here at the bottom, it's going to be still slanted. So if you wanted a flat bottom down here at this part, you would probably just want to do it separately. So if you wanted to slant down to here and then just be at depth, you'd probably just cut the letter in half or something like that. You wouldn't be able to mix this particular tool with other effects. So if I wanted it to come down halfway and then stop right here and the rest be flat, I would have to probably cut the letter in half and then apply 2 separate tool paths to that to get that effect. But that's still doable. It's definitely not, that wouldn't be terribly difficult to do if you wanted to mix those particular things together to create an effect like that. If you were to do this in 3D, you would have to use a ball bit, yes, to kind of create that flat bottom. But because this is a flat toolpath to begin with, that's just angled down a little bit, you get a little bit of a different effect. But good question, though. Good question. Any other questions?
I don't see any right now. I think you covered it pretty thoroughly.
Good deal. Yeah, no, this is one of those really good topics in EnRoute. I believe that a lot of this stuff you can do in the Plus version of EnRoute. So if you have EnRoute Plus, a lot of these toolpaths are available to you. And so you don't have to have the Pro version of the software to get to do these types of 3D tools. So that's also the other benefit, is if you're running a little bit lower version of EnRoute, you can still get some of these nice 3D effects without having to go into all the 3D work.
Perfect. Okay, thank you so much, Aaron. I think we'll wrap it up for today. Thank you, everyone, for attending. We do appreciate all your questions, and we will be having our next EnRoute webinar. Looks like it will be on November 17th. So same time, 10 o'clock Mountain Standard Time. And on November 17th, we'll be discussing how to create 3D slices in EnRoute. So Aaron will get to go over that next month, and we hope to see you all there. Have a wonderful rest of your day. Thank you.
Yep. Bye.